So what we're going to do is we're going to implement this member-wise copy operator for our list of integers so that instead of getting just a shallow copy where the head pointer of L2 just points to the same thing that the head pointer of L1 points to, we actually make a copy of the linked list of L1 and place that copy in L2. So here's how we're going to do it. And this assignment is going to look like this. And once we overload operator equal, then we'll get a separate copy. Now if you think about it, remember the example where we read integers from a file. And we can draw inspiration from that example. What we're doing here is if we just do a traversal of this linked list, we process the integers 5, 10, and 15. That's exactly the same order these integers appeared in the file. So if you kind of draw an analog between the elements of L1, 5, 10, and 15 as being in a file, that gives us some ideas about how we're going to construct this list. So instead of reading these numbers out of the file, we're just going to read them by traversing this linked list. And you're going to see some of the same code patterns that we saw in the read method of the list events class. So as we're doing this traversal, we're going to have a pointer. Let's say that it's going to be called the original pointer. That is going to be the pointer that we use to do the traversal of this list. Then we're just going to have another pointer that, like temp pointer, always points to the end of the list. And I'm going to call that copy pointer. Since this will be, we have to differentiate. We can't just use temp because it's not clear which object it refers to. Whereas here, if we use the original pointer, we know that points to the thing that we're copying. Copy refers to the thing that we're copying into. And what we're going to do here is the first element that we copy, which will be 5, we need to make copy pointer and head pointer point to it. This is exactly what we did in the read method. And we can test that by seeing if head pointer points to null. Well, once head pointer doesn't point to null, we know that we're always adding on to the end of the list. So we're going, since we're traversing using original pointer, we're going to be advancing original pointer. Then we check to see if head pointer points to something, and if it doesn't, we know that we're going to add it on to the end, and then we're going to advance copy pointer. And we're simply going to do that until original pointer points to null, until we know that we've traversed the entire end of the list. So that's how this copy operation is going to work in the simplest case. Now let's say, for example, that before we start our copy, L2 actually has a list in it. So just like what would happen if we called read on an object that already has a list in it. Same thing here. What happens if L2 has nodes? So we're going to have to check to see if head pointer of L2 points to null. And if it doesn't, then we're going to call the clear method to remove the elements of this list. The other thing that we have to worry about is self-assignment. What would happen if some programmer types L1 is equal to L1? What we're going to do here is we're going to see if the object and the parameter are the same object. And if they are the same object, then don't copy. Okay? And this is going to give us an illustration of a really good use of the this pointer. So keep in mind that this will be the parameter, And we can use the address operator to tell us where it resides in memory. But how do we know where L1 is? Where is L1, the object? Not the object. So again, L1 is going to be the parameter, but it's also going to be this object. So where is L1? How do we know where an object is in memory if we're in the scope of the class? Well, this pointer so this is going to be a good use of the this pointer. So we can actually compare using the address operator on the parameter with the address that this holds. And if those are equal, the same address, that means it's the same object. So those are the three things that we've got to worry about. We're going to make a copy. That'll form the bulk of the implementation. We've got to worry about what happens if the target of our copy has nodes. We have to call the clear method to get rid of those. Otherwise, we're going to get a memory leak. Then we have to check for self-assignment. And you'll see all of these elements in our implementation.